the thing we're going to go over in this video is actually useful for calculus and for pre-calculus students. It's useful for pre-calc because this really is just boning up your algebra skills so that you can do more things with these rational functions. In calculus is where you have the payoff of being able to do this, specifically with being able to do a process called integration on these rational functions. But whether you're in pre-calc or in calc, this is a useful thing to be able to do. So let's get down to business. We want to find the partial fraction decomposition of these, which means that we want to make them equal to a series of fractions with smaller denominators. This can be a little tricky at times. Let's start, as always, with numero uno. Okay, you might try to, as I did at first, try to make this factoring by grouping. So x to the third times x minus 2 plus, and then 2x minus 1. Well, this is not actually a factoring by grouping pattern because the things inside the parentheses aren't the same in the first and the second case. So, and this is not going to be a winner. We're not going to be able to do it that way. It took me a minute to see this, but check this out. The way that you can do this best is by looking at this and this. So x to the fourth minus 1. And then write it like in this order. When I at first did this, the reason that I figured maybe it would be a good idea is that I at least have the 1, 1, 2, 2 pattern, almost like a factoring by grouping sort of thing. But then something kind of cool happens. Factor the x to the fourth minus 1 separately. That will be x squared plus 1 times x squared minus 1. And then I'm going to take a minus 2 out of the second part. And that will be, actually, I'll do better than that. I'll take out a minus 2x. And then that's going to leave me an x squared minus, x squared minus 2. Right? Did I do that right? Minus 2x cubed plus 2x. Nope, sorry. That would be minus 1. My bad. X squared minus 1. Okay. So at this point, you might be looking at it and saying, oh, goody. Yeah, this is like sort of secretly factoring by grouping because we've got the x squared minus 1 in both places. And you're right. So this is x squared minus 1 times, and now I'm going to do this part and this part separately. So x squared minus 1 times x squared plus 1, and then minus 2x. And this, of course, can be written as x plus 1 times x minus 1. That's factoring the x squared minus 1. And then this is x squared minus 2x plus 1, which is x minus 1 squared. So this becomes negative 2x squared plus 5x minus 1 over x plus 1 times x minus 1 to the third power. What we want to do now is set this equal to the thing that lets us solve for the constants in the partial fraction decomposition. So remember that when we have repeated factors, we need to account for each number of copies of the factors. So this is going to be equal to some number a over x plus 1 plus some number b over just one copy of x minus 1, another number over 2 copies of x minus 1, and then another number over all 3 copies of x minus 1. Multiply on this equation by the entire denominator of the left-hand side. If you multiply by this, then the entire left side denominator goes away, and you end up with this, negative 2x squared plus 5x minus 1 equals, and now it's a question of how much cancellation is done. A times x minus 1 to the third plus b times x plus 1 times x minus 1 squared plus c times x plus 1 times x minus 1, and then plus d times x plus 1 all by itself. Sometimes you can use a little bit of a shortcut to get certain things for free, and we can do this here to get a couple of the variables for free. We're going to get, well, first we'll put in x equals 1, and this will turn into, on the left-hand side, -2 plus 5 is 3, minus 1 is 2. So that's 2 equals, and then look at this term for term. If I put in x equals 1, then this is 0, this is 0, this is 0, and this is the only term that survives, right? So if I put in x equals 1, what I'm doing is turning the right-hand side into something very, very easy. It becomes d times 2. Divide by 2, and I get that d equals 1. So d equals 1. I'll put that up here to keep track of it. Now I'm going to put x equal to -1. And let's see, is that going to do me any favors? Well, yeah, because that gets rid of this and this and this. All right, so what that ends up with is -2 minus 5 is now -7. Minus 1 is -8 equals a times -2 to the third power. -2 to the third is -8. Divide by -8 on both sides, and I get that a is 1. So d is 1 and a is 1. For the other ones, there's really no way around it. I do have to actually go and solve a big messy system of equations. Let's figure out what those equations are going to be. I have to expand this out. So I have -2x squared plus 5x minus 1 equals a times x cubed minus 3x squared plus 3x minus 1. Here I'm just using how to expand out a binomial using Pascal's triangle, plus b times x plus 1 times x minus 2x plus 1 plus c times x squared minus 1, that's convenient, plus d times x plus 1. And what this gets me is, I know that we know the value of a and d, but I'm keeping them as a and d just for now. We'll put them in a minute. This is going to turn out to be, let's see, from this first term, it'll be a, what is the most efficient way of doing this? I'll write them all out for now. ax cubed minus 3ax squared plus 3ax minus a plus b times x cubed minus 2x squared plus x squared minus 2x plus 1 plus cx squared minus c plus dx plus d. So the x cubes will be a plus b. That's going to be what x cubed is. That is this term and this term. And then the x squareds will be -3a, so that's that. And then -2 plus 1 is -1b, so that's minus b, plus c, x squared. Now the x's, 3a plus b. Oh, sorry, I should have done more of that. That's 1 minus 2 is -1, so that's negative b. And then plus d. Those are the x's. We're almost done, don't worry. And then this is negative a plus b minus c plus d. So all of these things must be equal to their corresponding coefficients on the left. So what this one tells me is that a plus b must be equal to 0 because there is no x cubed term on the left. I already know that a is 1. A is 1. So b must be -1, and I can keep track of this up here. The only thing I have left to do is find c. And for that, I can go and consult with this. I know that -a plus b minus c plus d must be equal to -1 because that's the constant term on the other side, right? So I'm going to plug in the values that I already know. -1 for a plus another -1 for b minus c, which is currently unknown, plus d, which is 1, must be equal to -1. -1 and +1 cancel out. -1 and -1 cancel out. So I get -c equals 0. So what this tells me is that the partial fraction decomposition of this must be equal to this. I'm going to put the a over the 1 plus, a over x plus 1 becomes 1 over x plus 1. And then I'm going to take into account the minus sign on the b by doing subtraction. 1 over x minus 1. The c is 0. So instead of writing this, I'm going to just not write it at all. And then d is 1. So it's going to be 1 over x minus 1 cubed. And this right here is the partial fraction decomposition. I think that this has already been long enough. I wasn't anticipating it would take such a long time. So let's say that you can work on the other one if you want, but we'll stop it here.